Example 3, we're going to sketch the graph of f of x equals x squared minus 2x over 4 minus 2x, and we're going to compare it to the graph of f of x equals x squared plus 2x over 4 minus 2x. So the only difference between these two equations is this is a minus sign, this is a plus sign. This has already been sketched for us with technology. You would not be expected to sketch this one by hand, or would I ask you to sketch it with technology, but you may have be given graphs. So that's what we're going to use as a strategy. So this is already drawn for us. But let's go to sketching this one. So the first thing I want to do is see if there's any way to simplify it, because if something cancels out, then we're going to have a hole in the graph. So I factored out an x. Here I'm going to factor out a negative 2 so that I can rearrange this and make this a positive x. So plus 4 now is going to be a minus 2. So these will cancel down now. And so we are left with, actually, let's just rewrite it very clearly here. So f of x is x over negative 2. Think about that as the coefficient negative 1/2 x, where x cannot equal 2. So there's my equation. So when we're thinking of our y equals mx plus b, we have our slope, and then our b value would be 0. So because this canceled, that means I have a point of discontinuity at x equals 2. So to find the y value, I have to plug it into the simplified equation. So y is equal to negative 1/2 times my NPV of 2. Those 2's cancel, so y is equal to negative 1. My point of discontinuity then is 2 and negative 1. So I want to make sure I put a hole in the graph there. So let's put in our scale. I'm going to go to 2 and negative 1 and make sure that hole is there. Then I'm going to graph the rest of this. So the y-intercept is 0. And my slope is down 1, right 2, which makes sense. I would have put a point there. Keep going, down 1, right 2. I'm going to extend it up 1, left 2. So I'm just going to keep that pattern going. And I've got a straight line, but there is a hole in the graph. So we're going to connect this, making sure that you do not continue it through the actual hole. Make sure you put arrowheads at the end. Okay, so I just want to make a little bit of notes about why do we have a hole in the graph? Why do we not have a vertical asymptote? Because we're going to be comparing these. So for here, the NPV is x cannot equal 2, but because x minus 2 cancels, there is a hole in the graph. Now, when we compare this to this graph right here, let's have a look what would happen. So the same idea in terms of, I would always still factor. So when we factor this, I just want to show you that nothing canceled, okay? But that's still helpful. It still shows me. I still want to state my restriction of x cannot equal 2. So that's what's graphed down here. So there's a vertical asymptote then at x equals 2. Now on the screen capture of this technology here, most likely a graphing calculator, it doesn't actually show the asymptotes. So we're going to draw them in. So I know for sure that it's at 2, and you can kind of see, but now I can actually label that. I know for sure that that's at x equals 2. Okay, now there is no horizontal asymptote. You can tell there'll be an oblique asymptote because the degree in the numerator is 1 more than the degree in the denominator. I can tell based on the shape too. So I don't know how perfectly I'm drawing this, but I can tell that it approaches that asymptote. So I can see that there as well. I don't need to label it. I'm just showing you that. If I was to find it, I would do synthetic division and we would get that tail end of the equation, and that would be the asymptote here. So why is there an asymptote instead? Because in your equation, your x minus 2 does not cancel. So x minus 2 does not cancel. Therefore, x equals 2 is a vertical asymptote. Okay, so it's a vertical asymptote. It's not a hole in the graph. Okay, and as I mentioned, there's no horizontal asymptote. So this is just sort of a side note. There is no horizontal asymptote. And then we'll just say there is an oblique asymptote. So when you're analyzing some graphs, those are things that may come up as well.